Good morning. We're going to start today's lecture, the introduction of mechanics. Do you have any idea what is mechanics? Maybe in basic mechanics you have studied. Mechanics is such a thing that where if you have some force on something, right? If you have some force on something, or how does it reacts? Understand this one is called mechanics. When some force applied on something, right? How does the body reacts? That is called mechanics. To know these informations, to understand this information, that is called the mechanics or study of mechanics. Suppose if you take 50 kg bag on your head, how does your body reacts to this 50 kg? To understand this is called mechanics. While you punch to your friend, either face or either in muscle, doesn't matter. How does his body resist the force? That is called mechanics. Okay, so then you understand. So now, if you understand now, the example of the book will be very easy. Physical science that covers the problem of bodies at rest or in motion. The body can be at rest condition or it can be in the motion. Okay, due to the forces acting on the bodies. Okay, so while you are having the rest condition, that is we consider the static, while this body is in the motion condition, that is equal the dynamics. That's the things. Okay, no challenge here. So if you know that Newton's third law, same amount of force, same amount of reactions, whole mechanics, whole mechanics is based on this theory. If your body can resist, or if your parts of your body can resist 48 kg, but you are taking 50 kg, what would be the situation?
The
Body
weight
tends
will
to
fall.
bend against the weight.
That will fail for weight.
We cannot lift up the weight
The failure.
or stay in a static position.
So
Okay.
basically this is the status of failure, right? In
Yes,
more
sir.
broadly, if your neck can take 48 kg, your backbone can take maybe 80 kg, your legs can take maybe 100 kg. So if I say what is your capacity of taking load?
Sir,
How much?
48. Yeah.
48. Why?
Sir, because sir, neck is the main point to connect that connects the body with the head and then with the load.
No, I'm not happy with your answer. Anything else? Anyone can try?
So if we uh, put over 48 kg, then our body will don't carry the load, sir. It will
Anyone else
bend.
can try?
So our neck is connected, connecting our head with our body.
Mm-hmm.
That's why load first to go to the neck and then body.
It's okay,
Legs
but I
or
want very
spine.
specific answer. Anybody can try? Anyone else? Still more answer I want. Okay, the question is that your neck can take 48 kg, your backbone can take not backbone can take 80 kg, and your legs can take 100 kg of load, right?
100 kg.
So what happen
Yes,
if
sir.
you apply 50 kg? That is my question.
So neck will be broken.
Very good. That is the exact answer, and to be very specific. You understand? Neck is
Yes,
connected to the body and so on, so on. This is not our concern now. In the initial phase, we can see if we apply more than 48 kg of load, right, the neck will
yes,
break.
sir.
So once neck is breaking, that means the total failure of the structures, right?
Yes, sir.
Now
Yes, sir.
you can diagnose so many things, what kind of failure it might be. Okay, so the questions I asked to you like this, right? So if you apply 50 kg suppose on your head, and you find that your neck can take 48 kg, right? Your
Yes,
backbone
sir.
might take 80 kg, and your legs can take maybe 100 kg, right? So the question was that if we apply more than 50 kg, sorry, more than 48 kg or 50 kg on your head, what would be the situation?
Neck will be broken.
Neck will be broken, right? So this is the understanding we know, right? So how
Yes,
we
sir.
can find? By checking the capacity of neck, right? So how to check the capacity of neck? Suppose this neck, if you consider a member, suppose you can consider this neck is a member.
Yes, sir.
Okay, very good. So it is having some sort of load here. Okay, forget about the
Right.
load now. Just forget about the load now. It has some cross-sectional area. Okay, it has some cross-sectional area, right? So if we
Yes,
know the
sir.
cross-sectional area, right, can we calculate the stress? So now if you consider the force and if you know the area, so we can find out the passing due to the 50 kg, if it is a load, how much stress it will develop. So this is called external forces coming through this, right? But these materials, this these materials, or if our neck is the materials, kind of materials we have, it has own capacity. So which one we consider? The 48 kg I said. So we can check the internal stress also. So you can consider the 48. If the area is 1, so that is maybe 48.
48.
If you consider area is 1 and load is 50, it is 50. Do you understand?
Yes, sir.
Yes, sir.
So now you can understand that the stress of this neck or capacity of this neck is 48 maybe megapascal,
Okay.
right? Or
Yes,
maybe
sir.
megapascal MPa. Suppose forget about the kg now, and this is maybe 50 megapascal. Okay, so now here you can see that usually the neck can take stress up to 48, but we are applying 50, so that's why whenever it is exceeding the 48, it is going to break. Now the situation is that how does it break? So what is the type of forces we have? We have four kinds of forces. What are the forces? One force you can consider the axial, either this way, hmm? This way axially, right? It passing through the axis.
Exist.
Okay, it might be like this or it might be like this. Okay, so this is in
Yes, sir.
compression, this is in tension. You understand?
Yes, sir.
Okay,
Yes, sir.
this is one situation. So these two are for the axial situation. Another force you might find, shear force. Okay, suppose you,
Shear force.
yes, shear force. So shear force is the basically sliding force, so which is parallel to the cross section. So if you consider this is kind of force you are giving and it has a tendency to break here, right? So which are the resistance force is helping not to break, that is the shear force. Do you understand? Which force is passing through parallel to the cross section? please do not misunderstand. Do not misunderstand. Try to understand the key points.
So, so shear force is a vertical force or
I said axially.
Parallel force to the
I said
axis,
axially,
y-axis.
axially to the axis, right? If this
Yes, sir.
axis is y-axis, that is this kind of force. If the axis is x-axis, it might be this kind of force. So these directions can be changed as well, right? So if this force is compressing, that time we will find this is the axial force, which is compression. This is the axial force which is in tension. This is in tension, this is in compression,
Oh, tension.
right? Okay.
Right, sir.
So similarly, if you find your member is like that, it's in horizontal movement. Okay. So if you apply the load like this, it has a chance to break on this axis, right?
Yes, sir.
It will break like this, right?
Yes, sir.
So whenever you take chocolates bar, whenever you take the chocolate bar, if you break it, how does it look like? It breaks here, right? You can see the cross
Yes, sir.
section. So the force you apply by using thumb finger, it is parallel to the cross section. Parallel, right? Similarly, if you consider
Yes,
this is another body. If you apply load here, right? And if you apply load these directions, so there is a chance that you will get a breaking point here, right?
Yes, sir.
So I will look with respect to this cross section where it is breaking, these forces are parallel. Force is parallel to the cross section. Force is parallel to the cross section. So this is called the shear force. So usually shear force is denoted by V. Okay, another force we have the torsion. Suppose this is a...
Sir,
Yes, sir.
in the compression force, here also force is parallel, so it is also shear force.
Which one? This one?
No, sir, compression force, sir.
Here?
Compressive force. Yes.
Yeah, this one?
Here, forces are also parallel, sir.
Okay, this is a good point you asked, but you should think the cross section. Which cross section you are considering? Have a look for this one. Okay, I should give you another example. Suppose this is a body, right? So if any force is applied here, right? Suppose this force is F. So if you consider this is the cross section, with respect to this cross section, this force is perpendicular. Are you getting my concept?
Yes, sir. Yes, sir.
So for this cross section, this is axial force, because this force is perpendicular to this surface. You understand? But
yes, sir.
But for this section, for this cross section, this force is acting parallelly.
Yes, sir.
So for
Yes,
this
sir.
section, this same force is acting as a shear force. So if you are considering the section, if I name it section V, this is with respect to this this plane or this cross section, this F is the shear force. If you consider, okay, can I use the multicolor? If you consider this one, right, this plane or this area, okay, so that time this force would be axial force. Now is it clear to you?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay.
If perpendicular, that will be axial, or if parallel, it will be shear force.
Exactly. It depends on the plane or cross-sectional plane. Same force can be axial, can be shear if the cross-sectional plane changes. So similarly here, I considered that this force is the cross-sectional area for this. So with respect to this cross-sectional area, these forces are parallel. So that's why I'm considering these forces as a shear force, B force, right? And here you can see that
Yes, sir.
this is the cross-sectional area, right? This is the
Yes, sir.
cross-sectional area. So that's why this is perpendicular with respect to the cross-sectional area. Suppose if you apply some twisting force, so that time it generates some twisting force that is called torsion. Another situation you might find, which might be very familiar with you, if you have fixed support here, right? So
Right, sir.
while you try to push it down, what would be the scenery? This member will try to resist here. This resistance is against the bending. If you do not have this resistance, what will be the situation? This member might go like this, right?
Right, sir.
Do you understand?
Yes, sir. Yes, sir.
So, but this resisting force or this resisting bending force is not letting this member to bend like that. So that's why we call this is the moment, right? Or bending resistance force. Do you understand? So these four kinds of forces will be highly required for you. As I said, back to the main examples, as I said, if the capacity of neck is exit, that time the neck will fail. So now can you tell me what kind of failure it would be? Because you already understand the type of forces. So what kind of forces, due to the which forces it fails, you can name the failure on that. That would be axial failure. So now how can we say this is the axial failure? Because we can see that with respect to the neck, the force is acting
Vertically
vertically.
Perpendicular.
or axially.
Yes. So this is
Yes, sir.
axially. So this is perpendicular with respect to the cross section. In more to add, you can say this is axially in compression. So the failure might happen axially due to the compression force. Okay. So while it will compress, you know it will break somewhere, right?
Yes, sir.
You already have seen in the compression test of a cylinder. Okay. Now this is one kind of failure, you understand. Now what happen if I say that another force is acting this head, and due to the force, this kind of force, which kind of failure will be happening on the neck if you have another force is like that and your neck breaks here?
Sir, how this force will come? Yes, sir. B force.
Maybe you are pushing your friend's neck.
Shear force happens, sir.
Yes. So if due to this force fail, what would be the failure on your neck?
Shear failure, sir.
Shear.
So if someone is just trying to twist this neck, and if this neck fails due to this twisting, that would be torsional failure, right?
Yes, sir.
Yes, sir.
So now you at least understand four kinds of forces. So now we can go back to the lecture that we plan to give you. Now here you can see. Mechanics of materials is a study of the relationship between the external load on a body and the intensity of internal loads within the body. So what does it mean? How much load you are giving as an external load, and what is the intensity or what is the reactions on body or what is the feelings on the body, right? So these things. If on structures, that is called mechanics of structures. And this subject also involves the deformations and stability of a body when subjected to external forces. Okay, so when you consider some external forces, so that time it might deform. So now I hope you understand what is elongation, tensional force, what is compression force. So if you find this force is trying to elongate, you can see this force is pulling. So it is feeling the tension. If you take a section here, what will be the sectional view? The cross-sectional view would be like this.
Square.
You understand the cross-sectional free body
Yes,
diagram?
sir. Yes.
So that's why I gave you the assignment on free body diagram. So you can see if you take a section here, you'll find the forces tension. Similarly in compression, you can see if you take the cross section here, you will get the cross section is like this. So while it is in compression, so that time you will get the shortening. It will compressed. So it will compress your structures. And in case of the twisting, so due to the twisting force, you will get the torsion. While you'll just move to the twist, and finally come to the bending moment. So external forces and body forces. So in cross section, what are the forces you'll get? This is your body forces, right? And what are the force you applied externally? That is called the external forces. Suppose, just for an example, what we just studied today. So many informations we studied, but basically we studied these four forces, and additionally I just add the failure patterns. Maybe you have studied this failure pattern in your basic mechanics also. So who understand these four forces? Axial force, shear force, torsion, and the moment. Is there anyone have any confusion with these four forces? Suppose this is a object. This object has 6 cross-sectional face. How many? 6
6.
cross-sectional face, right?
Right, sir.
So if you consider one load is applied here, another load is applied here. Okay, this is F1, this is F2,
F2.
and this cross section is A1, and this cross section is A2. So just listen to me carefully. For A1 cross section, F1 is axial force. Is that okay?
Yes, sir.
Yes, sir.
For A2 cross section, F2 is axial force. It's also okay?
Yes, sir.
Is it clear now? F1 is
Yes.
axial force for A1, F2 is also axial force for A2. Both are axial force. Both can be shear force. This is V1. If you consider this is V2. So V1 is, if you consider this the V1. V1 is shear force for A2 and V2 is shear force for A1. Because this is the V2 which is parallel with respect to the A1, right? And this is V1 which is parallel with respect to the A1. Keep in mind which cross section you are considering, that should be considered either it is parallel with respect to the force or perpendicular with respect to the force. So we know stress is sigma equals to force over area, right? So this normal stress is how many types? Two types. One is compression, one is tension. Okay, so if you find this is acting, it is giving the this is the compression. If you find this is like this is the tension. So due to the tension force, it will be tensile stress. Due to the compression force, due to the compression stress. So these two are the normal stress or the axial stress. Similarly, if you consider the shear stress, if you consider some shear force, so due to this, what would be the shear force? Shear stress, that would be the shear stress. So normally we consider, we show the shear stress is with the tau V over A, right? But here you can see that why stress is important to know the capacity, right? Here you can see this is a bar 1 which is carrying 50 Newton load. This is a bar 2 which is carrying 5000 Newton load. So initially, what is your opinion? Which bar is strong?
Sir, bar 2.
Second one.
sir. Second one.
Bar 2. So being an engineer, this is a very wrong answer. Because you cannot say which one is strong. Why?
Why, sir?
Because you don't know the stress capacity of these bars. What is the stress on this bar? You don't know. You are just physically seeing that, or you can see that okay, bar 2 is taking more loads, are 5000 Newton, and bar 1 is only 500 Newton. That's why bar 2 is stronger. So how do you decide which one is strong? So that's why you need to find out the stress. That per unit area, which one is taking higher? So which one can take more? That would be more stronger. So now we need the area. We cannot say bar 1 or bar 2. We need the area to compare this study. So they consider that bar 1 cross sectional area is 10 millimeter square and bar 2 is 1000 millimeter square. So if you want to calculate the stress force over area, right? So
Yes, sir.
the force is 500, area is 10.
10.
So stress is 50. Stress is 50 megapascal, right?
Yes, sir.
Yes, sir.
And this is area is 1000.
Then 5 ampere.
So this is 5 megapascal. So this one is 50 megapascal stress and this one is 5. So what is the indication of this? Megapascal means what? Each millimeter is square, each millimeter is square, it can take 50 Newton load. And each millimeter is square, it can take only 5 Newton load. So this is 10 times stronger than this. So bar 1 is 10 times stronger. Do you understand? So this is another reason that we need to study the stress to find out the strength.